So we could use our knowledge of the stability of our bases to figure out the equilibrium and the choice of reagents. So if we have an acid-base reaction here, the equilibrium will favor the weaker acid. So you can think about it as we've got two acids here, acid A and acid B. Both of them want to get rid of their proton. The one that's going to be more successful at getting rid of its proton is going to be the stronger one. So you're going to have more of the weaker one. It's not going to be able to get rid of its proton. So the weaker acid will be the one that's made. Also, if the conjugate base is more stable, equilibrium will favor its formation. So we can look at it both ways. The more stable conjugate base is going to have the stronger acid associated with it. So let's look at an example here. We have our we've got our acid and our base. So let's base. It's going to gain a proton, and this is our acid. This is our conjugate acid and our conjugate base. So we'll want to compare at our two bases and see which one is more stable. Well, here we have a negative charge on a carbon, and over here we have a negative charge on a nitrogen. In general, we can go back to our system where we go atoms, resonance, induction, orbitals. This will be the more stable. Okay, that means that this is the stronger. This is a stronger acid. And so our equilibrium is going to be this direction. So let's look at another example. Here we've got our acid base. This will be our conjugate base and our conjugate acid. And now we need to compare our bases and see which one's more stable. So here we have hydroxy. The negative charge is just on that oxygen. Here we have a phenol, and it's got a negative charge just on this oxygen. But we also are going to have resonance involved with this. This negative charge can move down here and move into the ring. So this negative charge is going to be spread. It's going to be here, here, and here. So this will be more stable. That means this is the stronger acid. And we're going to favor the weak acid, so this will go. We can also use this to figure out whether a reaction will occur or not. So let's look here. In each case, identify whether the reagent shown is suitable to accomplish the test described. So we want to know if we can protonate this compound using water. So these are our two reactants. We need to write out our equation first. They didn't give it to us this time. And water. Our products are going to be this initial compound but with a proton on it. And hydroxy. Okay, so this is our base, and this is our conjugate acid, So this must be our acid and our conjugate base. Okay. Now we need to look and see, we need to compare our two bases and see which one is more stable. So here we've got a negative charge on a nitrogen, and here we have a negative charge on an oxygen. So that's going to be more stable, and that's because it's an oxygen and not a nitrogen. And so we're going to make more of the more stable product. Okay, we want to see if we can protonate this using that. So we've got extra electrons sitting there, and this is our other reactant. Drop, right? If we're going to protonate it, it's going to be, it'll have a proton on it. We'll just, usually we wouldn't draw it, but we'll put it on there to show kind of what happened. And now this is negative. So let's figure out what happened here. This is our acid, because it's losing a proton. This must be the conjugate base. This is our base, and this is the conjugate acid. So we want to compare our two bases and see which one is more stable. Here we've got a negative charge on an oxygen. Over here we have a negative charge on a nitrogen. Nitrogen is more electronegative, and so this reaction will go. Okay, because we're comparing oxygen and nitrogen. Okay, so let's look at our last example of these. Can we deprotonate this using the amine ion, sorry. So we've got our ethene, and we're gonna, this is our, I'm gonna draw it out like this. Get some extra electrons on here and a negative charge. We're going to make, we're going to deprotonate this, so we'll have carbon, hydrogen, hydrogen, double bonded to a carbon with one hydrogen. We've got a negative charge here and some extra electrons. And then we've got just plain old ammonia here and no charges. Okay. So let's see what's happening here. This is our acid, and this must be our conjugate base. And this is our base, and this is our conjugate acid. All right, so we need to compare our two bases. Here we have a negative charge on a nitrogen. Here we have a negative charge on a carbon. So the nitrogen is more electronegative, and so this reaction will go in the reverse direction. So this will not work. I can't deprotonate ethene using an amine ion.